Hello everyone! I'm going to be telling you about the Big Bang Theory now, but it's not a series, it's the actual astrophysics theory of how the universe may have started, okay? So if you look at my previous video, you will know that Edwin Hubble did make some discoveries where most galaxies were showing redshift, and this led to the idea that maybe everything, the universe was expanding. And if you run back the theory, you would have seen that maybe the universe was much smaller before, and if you can keep, moving backwards, maybe the universe was a tiny little bit of point that suddenly, for any reason, expanded outwards very suddenly, okay? So this comes from the observations of the redshift, okay? So the fact that the galaxies were moving apart led to two important ideas. One is that the universe itself may be expanding and that have been much smaller in the past, and the other was that the universe may have started by exploding or a rapid expansion outwards from a single very hot and dense point, and we call this the Big Bang. Now, as everything in science, you try to give an explanation to the observations that you have. And the Big Bang was not the only theory about the observations that we had about redshift. Now, there was another theory, quite famous, that is called the steady state theory, that said that the redshift observations were happening because the universe had white holes. And the white holes would do the opposite of black holes. So the white holes would eject material to the universe. So you would have a steady state universe, meaning no beginning and no end. It was always there, just the way that it looks like now. However, things were moving apart because there were these white holes that would appear out of nowhere everywhere, and they would create space because they would put matter into that universe, okay? Now, redshift was showing that things were moving away from each other. So the redshift could be explained using the Big Bang theory or the steady state theory. So what scientists need to do is go and look for more evidence, right, to try to prove that their theory is correct. And the other evidence that came for the Big Bang, and that made it win against the steady state theory, is this one called the cosmic microwave background radiation, okay? Now, so the Big Bang ended up by winning. Let me just tell you that there is another evidence for the Big Bang, which is the amount of helium in the universe, and they will all be explained in the next slide, okay? So, for the Big Bang, and the reasons why we believe the Big Bang theory is the theory of how the universe may have started, okay? That says that the universe started from a very hot and incredibly dense point and has been expanding ever since, is number one, the redshift, the cosmological redshift, okay? So it's not the redshift of having an ambulance passing by, it's the cosmological one. So from the cosmos, what we see around us in terms of the universe, okay? Galaxies moving away from each other, okay? Then the cosmic microwave background radiation, that I'm going to tell you a little bit about it, and then the amount of helium in the universe, okay? So these are the three evidence the three types of evidence that we have that makes us believe at the moment that the Big Bang is the best theory to explain how the universe may have started, okay? So the explanation of all of these, or summary about all of these: the redshift, the further from us a star, the further from us a star is, because I know what is written on the slides, but I have an idea, but sometimes I want to read it to make sure that I'm not, missing out something, and then these things happen. So the further away a galaxy is from us, the more the light is redshifted. Okay, distant galaxies are moving away from us, and the further away the galaxy is, the faster it's moving away from us. So this is an evidence for generally expanding universe. This was evidence for the Big Bang. This was also evidence for the steady state theory. Now, cosmic microwave background radiation, this is not going to be the only video that I'll do about it, by the way. The scientists predicted that there would have been an afterglow after the Big Bang. So if this Big Bang happened, then we should have had this cosmic microwave background radiation to form. And if I'm not wrong, this was formed 10 to the power of minus 4 seconds after the universe, or after the Big Bang, okay? So the scientists did discover that there were microwaves coming from every direction in space, and this is believed to be the energy created at the beginning of the universe, just after the Big Bang, so about 10 to the power of minus 4 seconds after, okay? Now, these microwaves, I'll tell you a little bit more about them, but when the scientists were predicting it, they did predict that whichever radiation it would be in the microwave region. So when you find something that just matches your theory, your calculations, your assumptions, then this is great, okay? So this was really the thing that made us believe that the Big Bang is the best theory at the moment to explain how the universe may have started. And this was worth the Nobel Prize in, if I'm not wrong, 1967, okay? And then the other evidence for the Big Bang is the amount of helium in the universe, okay? So the early universe was very hot, so hydrogen could fuse into helium and form helium, okay? Again, go on a video about stars, I believe is in my other playlist called Classification of Stars, where I have the explanation about fusion, okay? Now, this amount of helium in the universe, it does explain the relative abundance of different elements in the universe. So because the universe would be very hot, I could have hydrogen fusing into helium, and then other structures making further fusion, okay, like for example stars. And the relative abundance of different elements in the universe, where hydrogen and helium make about 98%, but all the rest is there as well. The other 2%, or about 2%, is there as well, and it does match on our observations on how they were formed. It does match for evidence for a very hot early universe, okay? So all of these three are evidence for the universe starting with the Big Bang, okay? Now, this cosmic microwave background radiation, the story on how it was discovered was quite interesting, actually, quite funny in a way, a bit sad for the pigeons. But I did have here a video. Feel free to search for this video. I tried the link, and the link is not working at the moment. I tried searching from the video for the video's name alone. I couldn't get it to work either, but feel free to look for it. But basically what happened was scientists were looking for these microwaves coming everywhere from space, and they had this type of equipment, okay, to look for this radiation. At the same time, by coincidence, while one of the scientists was in a room with one of his friends did receive a phone call where another friend was kind of moaning to him. This other friend worked in a TV station, and he was moaning to him that they had this noise, this annoying noise, this background noise, and they couldn't explain it. And it didn't matter where they would move their antenna, they were getting this noise. And this actually caught the eye, or actually the ears, of the scientist that was looking for the cosmic microwave background radiation, because it looked like they were finding something that's what they wanted to find, okay? That they were looking for as well, okay? So at first, they thought that the reason for this interference, this annoying noise, was the pigeons, because there were pigeons nearby the antenna. So they decided to try to get the pigeons to move away. So they scared the pigeons out, and then they cleared all the droppings and all these things. And this didn't work, and then the pigeons came back. So unfortunately, they did kill the pigeons, okay? So they shot the pigeons, and they're like, right, now there's no more background noise. And guess what? There was still background noise. It was not the pigeons, poor creatures, that were creating this. This was the cosmic microwave background radiation that was coming everywhere from space. Cosmic, because it comes from space. Microwave, because that's the region in the electromagnetic spectrum where the radiation is from. Background, because it's always there, is always present. You cannot get rid of it. And then radiation, because it's radiation, okay? And this is a picture of more or less how it looks like, okay? And this became the Nobel Prize in 1967, if I'm not wrong, because they did find the evidence of the Big Bang, or they did find at the moment, you know, this is science, things can change from one day to the other almost, but they did find a very convincing evidence that there was this rapid expansion or explosion from a very hot and small universe, early universe, okay? So that's a little bit of the Big Bang theory and why we believe that's the best evidence so far, or the best theory so far, to explain on how the universe may have started. I will have another video telling you a little bit more about the cosmic microwave background radiation, okay? So this is me signing off for now, and you guys take care and see you in another time. Bye.